question that came in the IIT JEE 2025. So, and it is based on so uh, so this question is from the topic of the gravitation, and you fellows may have seen this question. So the question simply here is there's a solid sphere of mass m, radius capital R, exerts force F on a point mass. Okay, now a concentric spherical mass m by 7 is removed. What is the new force? So the question is, we have to figure out, once the mass has been removed, then what is the new force? Now see here, when you're talking about solid sphere, what do we, so let us make a solid sphere, and so suppose this is our solid sphere. Okay, what we are going to do is, so the mass of the solid sphere is how much? Its mass is m. Okay, its mass is m. Okay, now you are removing, now there is a point here, so we are supposed to calculate the force. So suppose this is the point at a distance, like whatever distance is there, so call it d. So how much is the force because of this mass? So I can write using the law of gravitation. So F is equal to, call this a point mass or test mass, m naught. So g m naught divided by d square. Okay, this is the force when the whole mass is spread uniformly and there's no mass has been removed. Now when you remove the mass, what happens is, so let us remove a mass concentric, and the sphere has to be concentric, and this is important, sphere has to be concentric. Now so if this is the center, we are going to remove mass from here. Now how much is, now the new mass of the whole structure is, now this whole structure is the m prime is m minus m by 7. Okay, this is the mass, so this will be 6m by 7. Okay, this is the mass. Now see, this this whole gravitational laws, they are applicable for point masses. Okay, and we can calculate and we can assume the mass of this whole sphere to be concentrated at the center only if it's symmetrical, or the mass is distributed symmetrically. Okay, now because of this removal of this small mass over here, we have disturbed the symmetry. So what we're going to do is, we can create something like this. Okay, so we are going to add mass m by 7 over it. Okay, same mass but with minus sign. So what we're going to do is, we're going to superimpose this cavity with plus m by 7 and minus m by 7. Okay, so it's like a cavity is there, so I'm going to add. So now, so this can be seen as a superposition of, now this whole system, what I'm going to create is, I'm going to create, this is now a combination of m 6m by 7 plus m by 7 and plus minus m by 7. Okay, now this will, now these two will combine to give me a symmetrical mass distribution. Again, this is going to create the whole sphere. Okay, and this part is a sphere. Now this is a sphere of mass minus m by 7. Okay, now we can figure out, now it's like, now the whole thing is like we have a, so we have a mass, or okay, let me use the distribution. So we have, it's like now we have a combination of mass m and combination of another one with, now this is mass m and this one is minus m by 7. Okay, and now we can figure out the force of gravitation here. Okay, now so apply the law of superposition, or we can use the, let's call it principle of superposition. So use the principle of, so principle of superposition. So if you use this principle, so we're going to end up with, okay, now because of the capital, because of the mass capital M, the force will be, so F resultant will be G M N naught divided by D square and plus G minus M by 7 into M naught divided by D square. Okay, so now just take the common, G M naught upon D square is common, and we are left with 1 minus 1 upon 7. Okay, so this will become G M naught upon D square into 6 by 7. Now this part, as we know, is the F. Okay, so this is what we calculated here. The F is here, this is your F. So we are going to replace this. So F resultant is F 6 by 7 times the initial F. Okay, this is what we have here. Okay, so the options were, the first option was 5 by 7 F, sorry, it was F by 7. Second option was 6 by 7 F. Third option was 5F by 7, and the fourth option was 3F by 7. Okay, so I'm gonna, hope you guys gonna like this video. Hope you find it full of informations.